Hi class, today's lesson is about gravitational force. This is class by Raj teaching for Physics Form 6 Semester 1. Today's learning outcome is to state and use the formula of Newton's law of universal gravitation. Newton's law of gravitational states that every particle in the universe attracts every other particle with a force. The definition or the statement is that the gravitational force, which is the attraction force, between two particles of masses m and m separated by a distance r is directly proportional to the product of the masses and inversely proportional to the distance square. Now, our lesson for today will be on Newton's law of universal gravitation. Okay, gravitation. Alright, Newton's law of universal gravitation states that the gravitation force, you see, when Newton was stating this law, he was stating that every particle in the universe attract every other particle with a force. Okay, so he said that the gravitational force of attraction, that means attraction between two particles. So I have two particles here. One is mass is capital M and one is mass is small m, separated by a distance r. Okay, separated by a distance r. Okay, separated by a distance r, is directly proportional. There is a force that exists between them, which is the force of attraction, F, is directly proportional to the product of mass, which is capital M times with small m divided by r squared. Okay, and since it's a force of attraction, so the why we have a negative is because the negative sign shows that it's a gravitational force, which is an attractive force. Okay, and it's the opposite direction of increasing r. So you have something like this. Okay, alright, so the direction is opposite to the direction of increasing r, that means it's in the decreasing r. Okay, so when you change your proportional sign to equal sign, you get F is equals to, you put a constant, negative GMM over r squared, where capital G is called as the universal gravitational constant, and the value is 6.67 times 10 to the power of negative 11 meter cube kg negative 1 s negative 2. And when you are using this formula, you not necessary to put the negative inside the formula, because the negative is just to show that it is an attractive force. So it's not necessary to put the negative. Okay, alright, so the gravitational force class, which is the F, if you look at here, is between two bodies form an action and reaction pair, which is satisfy Newton's third law. Which satisfy Newton's third law. Okay. All right. So that's all. To make a bit more extra explanation on this negative. Okay, when you are solving problem, it's not necessary to put the negative inside the formula or inside the solution, because the negative speaks about the direction. Okay, so it doesn't influence the magnitude. Okay, so the negative speaks about the direction, where it also tells you that the direction is in the opposite of increasing R. And also it tells you that the gravitational force is an attractive force. Okay? Alright, that's all.